Good morning. It's Tuesday, June 2nd. If you are following along and keeping up on track with us, today and tomorrow you are going to read Chapter 7, which is Earth's powerful forces of change. So your big question, I'm gonna put it out there today. It's how do weathering and erosion continually reshape Earth's surface? That's your big question. You are not going to answer it until tomorrow's exit ticket once you've reread this again. So today we are going to talk about weathering and erosion. I've created an anchor chart. We also are going to talk about chemical versus physical weathering. This is a little bit tricky, so I do not blame you if you are having a little bit of trouble with it. And then the last thing we're going to do is look at the multiple meaning word state. So let me go ahead and get started with my anchor chart that I drew. So weathering and erosion, they go hand in hand, but they are two different things. So we have weathering. This is the breaking down of rocks by water, wind, and ice. So weathering naturally just happens. You can see it happen on the roads. Like cracks can start to form or it starts to fade. Weathering naturally happens. Erosion is the movement of sediment, which is broken down rock. So once weathering has happened to rocks and it has broken them down, that's just weathering. It is not considered erosion until they move. So an example, if you've been to Lake Michigan, the beaches are getting further and further in because the water keeps pushing the sand, the sediment, right? It's the broken down rock. It keeps pushing it and pushing it and pushing it. So it keeps getting closer and closer to the shore. That's the best example I can think of. This is a little confusing. Weathering and erosion, you will read about it today. I will put this here if you need to hit pause so that you can review. I kind of drew some pictures. These are sediments that are supposed to be moving. This is the wind coming from like a wind cloud. And then I have to show you Susie right now. She is just being Suzu. She's being my little helper. So physical weathering changes rock without changing the minerals that they contain. So it's like, this is my pop can. I physically changed it. I crumpled it. It's still a can. I crumpled it though. It looks different because I did something to it. Okay? So here's an example. Temperature can cause physical weathering, okay? So I'm getting this example straight from the book to help you understand better. So rocks in the desert bake during the day beneath the sun's scorching heat. So as the rocks get hot, they expand. It's like when your hands get hot, they swell up. And then at night, when the sun goes down and the temperatures fall, as the rocks cool down, they start to shrink. When my hands are cold, my rings are loose. My hands are cold right now because this is popping right off. So expand, contract, expand, contract. This endless cycle gradually causes the rock's outer layer to crumble or flake off. That is physical weathering. Water causes physical weathering. It's doing it to our beaches right now. So water can seep into the tiny cracks in rock. And then if temperatures drop below freezing, the water can turn to ice. So that process is called ice wedging. I think I just gave you an answer for your exit ticket, so I'm sorry. Oops. Plants and animals also can cause rocks to weather. Tree roots can squeeze into the cracks in the rocks and cause them to break apart. But the minerals still stay the same. Chemical weathering breaks down rocks by changing the minerals that they contain. Rain is actually a very powerful chemical weathering force. When rain falls, it mixes with the gas carbon dioxide in the air, And then you can have acid rain. It is strong enough to dissolve some minerals in rocks. And then once dissolved, the minerals just wash away, which weakens the rock. Acid rain can, if you've ever been to like an old gravestone, or to an old cemetery where there are old gravestones, you might notice some of the lettering is not as deep as it had been when it was first done. Same with stone statues. An example would be the Statue of Liberty. She was not always green. She used to be like copper, but we had chemical weathering that caused her color to change. That would be like if this can sat out in the rain and then rusted, right? Physically, it would be different than what it is right now. Right now, it just looks different. So let's see. The big question, weathering and erosion, chemical, physical, weathering. Oh, and then the multiple. Sorry, I'm working at my kitchen table here and just running out of room. The multiple meaning word for state. So the first half of your exit ticket is going to be comprehension questions. The second half will be the multiple choice where you have to pick the correct definition. So the first definition for state is the condition of being a solid, liquid, or gas. So this water in my Yeti is in the liquid state. If I went and put it in my freezer, then it would be in the frozen state. So it would be solid state because it's frozen. Number 2 is one of the many smaller units of government that make up a country. So that's like Illinois, Indiana, Texas, California. You're probably hearing a lot of states on the news right now with all the COVID stuff because they're kind of announcing it state by state. And then the last one is a verb, which is to express something in speech or writing. So I'm going to state that your work is due on Friday at 5 p.m. So I expressed something in speech. The president gives a state of the union. So he expresses how the country is doing in a speech. This video was a little longer than I expected. Remember, tomorrow you are reading the same chapter. Good luck. I'll be on Zoom 9 a.m. to 11 a.m. Call, text, or email me. We are almost done. We can do it.